and welcome to the show, the 45th anniversary show of Once Upon a Christmas Cheery in the lab of Shakhashiri. 45 years, wow. Some of you weren't even born when we started in December of 1970. But we are here to celebrate creativity in science and in the arts. And we are joined by the varsity band from the University of Wisconsin in Madison and the director, Professor Michael Leckrone.
Hi. Hi. How are you?
Very happy to have you here.
We're delighted to be here.
Happy to have you here because science is fun.
2, 3,
it's joyful.
4.
Are you ready to have fun? Are you ready to learn? Well, let's get started then, because in my lab, we always obey the safety rules. And the first one, of course, is to have eye protection. I have my goggles on. Everyone sees that I'm putting them on. And I'm going to invite our lecture demonstrator from the chemistry department, Mr. Jim Maynard. Jim? Happy to have you here, Jim.
Hi, glad to be here. Thank you.
What experiment do you have for us?
Okay, so I set up experiments sometimes for the students in the UW Chemistry Department. I just wanted to work on a couple of them that I have here.
All right.
Okay, so I want to start with this. I have a can here, and a gallon can. It's a metal can, and inside it is a small amount of water.
About how much?
Probably 150 milliliters.
All right. And what volume is that can?
This is a 1 gallon can.
All right. So a small amount of water. Okay.
So I'm going to heat up the water in the can with this burner. So let's see if we can get a fire started. That's good. So while the can's heating up, what I'm going to try to do then is, as the water all evaporates, it's going to displace the air as it rises through. It's going to carry all the air away with it. And then what I'm going to do is I'm going to use this pan of water to cool it. And so what I think will happen is when the water cools down, that it will all contract and there'll be a vacuum drawn in here.
Okay, let me get this straight. So the water on the inside is boiling. It's going to be changed into water vapor. And the water vapor is going to come out from the opening there?
Right, and we're going to see that. We're going to see the water vapor because it's really hot. It's going to condense on the cold air, and that will let us know when it's boiling well enough for us to run the experiment.
All right, and so when the water vapor comes out, it sweeps along with it some of the air? Is that what you said?
Yes, indeed
okay.
It does.
So how do we know that something is happening here?
We have to infer that since the fire is going, and that since thermodynamics is in effect, that there is some heat being transferred to the water at the bottom. So now it just comes to patience. Sometimes when you run chemical experiments, you have to wait a little bit to see what happens. So I think we're ready to try it, don't you?
All right.
Let me just get my glove on. Safety first. Okay. Okay, and then it goes in here. You may have heard something.
I heard something, yeah.
I heard something too.
Yeah. Hey, this can is getting bent out of shape, Jim.
Yeah, it's a little excited. There we go. So we're just putting a little cold water on here, and what is happening is it's cooling off the water inside, which is becoming a liquid, right? And a liquid takes up a lot less space than a solid.
It looks like this invisible giant is crushing the skin.
Yeah.
Right?
You know what? Actually, a liquid takes up a lot less volume than a gas.
Yeah, and so the atmospheric pressure is
Yeah, that's
crushing
right.
it.
So now that there's a vacuum, the atmospheric pressure is crushing it.
Very nice.
Wonderful.
Very nice, Jim. That's good.
Okay. All right, I have one more experiment I'd like to run. Okay, and for this experiment, I'm going to need this tall glass cylinder that I have. And you may have noticed it's sort of in a water bath.
Yes.
And that's so it could be sort of warm. It's about 60 degrees C, or maybe 130, 140 degrees Fahrenheit. So I'm going to take this out. And as you notice, there's a mixture of clear and colorless liquids in here, or at least there's a clear and colorless liquid in here.
Yeah.
But as you can see, not a lot is happening right now. So what I'm going to do is I'm going to add a chemical that's called a catalyst, which is going to help this react.
So it's a colored catalyst.
It's a colored catalyst. You
All
may
right.
notice what color it is.
Yeah.
It's
all right,
red.
Right.
All right, so the catalyst goes in here and helps the reaction take place.
It's bubbling.
It is.
You're making a mess. You're about to make
I have
a
a
mess.
tray. You may have noticed the color changed.
Ooh.
That is evidence of a chemical reaction. So it started red, right?
And now it's green.
And now it's green.
All right, that's still
Those
going
are
on.
our Christmas colors. One other interesting thing about a catalyst we may notice here, once it gets done, is that even though the catalyst helps this reaction go along, it
Doesn't get consumed, right?
does not get consumed. As you see, the red color is coming
I
back.
see. Lift it up a little bit. Let me see.
Yay!
Yeah, there's
so
the
the catalyst helped this happen, but it's still here.
Very nice, Jim.
Thank you very much.
Thank you, Jim. Thank you very much.
Great.
Thanks. And now I'm going to do an experiment with this large inverted flask. It has a volume of 5 liters. It's empty. It looks like it's empty, but actually it has a gas in it. It's a clear and colorless gas. And there's a large amount of water down here. And there is a stopcock that is closed. And there's a rubber bulb that has a little bit of water in it. When I squeeze the water out of the rubber bulb, we're going to see what happens. So the first thing I'm going to do is to open the stopcock like this, carefully, and squeeze. And you see we're siphoning the water from the bottom beaker to the flask on top. The colorless gas that was in there is ammonia gas. Ammonia is very soluble in water. A small amount of water was in this rubber bulb, and as the ammonia dissolves, then we get a basic solution. We have an acid-base indicator in there, and the pressure gets less and the water gets siphoned all the way up. So this is the Ammonia Fountain experiment. You like that one? And now I'm going to move over here and do an experiment with this glass container. It has in it some water. It's sitting on a magnetic stirrer. I'm going to turn the light on so we can see it better. And I'm going to take a Teflon-coated magnet and put it right down the bottom and turn the motor on. And we'll see as I increase the speed. Let's see if I increase the speed some more. We're beginning perhaps to see what looks like a vortex. Actually, it looks like a tornado.
Toto and I are scared. I don't think we're in Kansas. Well, where are we?
Dorothy, you're in my lab. You're safe here.
It looks like you're doing some fun things. What are you doing?
We always do a lot of fun experiments in my lab here.
Oh, I like doing experiments. Can I do one now?
Of course. Right here?
Yes. I just need some eye protection.
Eye protection, yes, yes.
My experiment's on acids and bases. Do you have any milk of magnesia?
I have milk of magnesia here.
Wonderful. Now, I need 2 more items.
Yes.
Vinegar and a small amount of colored acid base indicator.
I have the vinegar and the colored acid base indicator that you asked for.
Well, and some distilled water.
That's what we have in this vase right here.
All right. I'm all set. To this container of distilled water, I'm going to add 50 milliliters of milk of magnesia. Then I'm going to add 15 milliliters of the universal indicator.
Carefully measured.
The purple color we're beginning to see tells us that the milk of magnesia, when it dissolves, it turns into a basic solution.
That's milk of magnesia is magnesium hydroxide. You're right, it's a
Yes.
base. But it's not very soluble, is it?
No, it doesn't dissolve quickly. Next, I'm going to add 50 milliliters of vinegar. Vinegar is a water solution of about 5% acetic acid.
Uh-huh.
I think we need more.
All right. All right, add a little more directly. Don't measure it, just add
All
it
right,
in.
all right.
All right, all right.
Now, the red tells us that we have an acid, while the blue tells us it's a base.
That's a very colorful transformation, Dorothy. I like that.
That is, and that's why I like it. The color transformation is very similar to a rainbow. Somewhere over the rainbow. Wait, I think I need some help. Somewhere over the rainbow, way up high, there's a land that I heard of once in a lullaby. Somewhere over the rainbow, skies are blue, and the dreams that you dare to dream really do come true. Someday I'll wish upon a star and wake up where the clouds are far behind me, where troubles melt like lemon drops away above the chimney tops. That's where you'll find me. Somewhere over the rainbow, bluebirds fly. Birds fly over the rainbow. Why then, oh why can't I? Birds fly over the rainbow. Why then, oh why can't I? If happy little bluebirds fly beyond the rainbow, why, oh, why can't I?
Thank you, Dorothy. Beautiful song and a wonderful experiment.
Thank you. Well, I'm off to do more experiments. Come on, Toto, we are safe here.
And thank you also to members of the Madison Youth Choir right here. Is one of you ready to do an experiment with me?
I'm ready.
You're ready? Come on over. What's your name?
I'm Raya.
Hi, Raya.
Hi.
Come a little closer. What experiments have you been doing?
Well, I've been working with the Bernoulli effect.
The Bernoulli effect? What's that?
Air movement.
With the movement of air?
Yeah.
Okay, would you like to show us?
Sure.
What do you need?
Do you have a balloon?
I have a balloon. Will this one do?
I believe so.
Okay. That's good.
Ta-da!
Surely there's more to the experiment than that, isn't there?
Yeah.
What? Yes? What else do you need?
Do you have a hairdryer?
I have a hairdryer. Someplace here, I have a hairdryer right here. Yeah. Will this do? All right.
so.
Come on closer.
Alrighty. Thank you.
You're welcome.
So, at the moment, if I let go of the balloon, it falls. Do you think I can suspend this in midair without touching it?
I'm not sure.
Well, I'll try.
It's your experiment.
So, here I go. I will turn on the hairdryer. Ta-da! So, as you, yeah,
That's very nice.
thank you. So as you can see here, the airflow from the nozzle of the hairdryer is suspending the balloon.
Can you suspend other objects too?
I can try. Do
Like
you-
what?
Well, do you have a ping pong ball?
I might have one in my pocket.
Should I do momentarily? Here I go.
Same experiment?
Yes, but with other objects.
All right. That's pretty good.
Should I try to do two at once?
Do it. You want to try to do two at once? All right, here you go.
Okay. Ta-da!
So, Bernoulli's effect, right? That's an experiment, actually, that not only you, but everyone can enjoy. And we have a whole bunch of experiments listed on the Science is Fun website. That's why I invite you all to visit our website, scifun.org, and try not only this experiment, but many other experiments that you will enjoy and have fun with, all together with the family members, with your friends, and with your parents, and with your siblings. So, Raya, what have you been doing here in my lab?
Well, my friends and I here have been experimenting with the chemical elements.
Chemical elements? Do you know any elements?
We know them all! There's antimony, arsenic, aluminum, selenium, and hydrogen, and oxygen, and nitrogen, and radium, nickel, neodymium, neptunium, germanium, and iron, americium, ruthenium, and radium, europium, zirconium, lutetium, and radium, and lanthanum, and osmium, and astatine, and radium, and gold, and titanium, and indium,
What great talent. Ladies and gentlemen, members of the Madison Youth Choir, right here. Thank you all very much. Thank you, thank you. That was wonderful. My next experiment will be done with liquid nitrogen. Liquid nitrogen is at minus 196 degrees Celsius. And I'm going to do this experiment where I'm going to take the liquid nitrogen out of this thermos bottle. I pour it on the top. It hits the tabletop, which is warmer than minus 196 degrees Celsius. It's a good and easy way to dust off the tabletop here. What I'm really going to do is take this balloon that has in it a gas lighter than air. The gas is helium. I'm going to put the balloon down here and put the liquid nitrogen on top of it. And now we see the balloon collapsing because the cold liquid nitrogen has cooled down the helium atoms that are inside the balloon, and the pressure is less than what it was before. Now, if I let go of it, it goes up when it fills up. What I'm going to do is cut off this. And there goes the balloon. Very cold liquid kept inside these insulated thermos bottles. And now I'm going to take a very bouncy rubber ball. It's actually a racquetball. And guess what I'm going to do with it? I'm going to put it in the liquid nitrogen just like that. Actually, what I'm going to do, I'm going to show you this. This is a thermos bottle. We call it a Dewar flask. And I'm going to put the liquid nitrogen and the ball in there so you can see it. The liquid is boiling because the temperature of the glass and the ball is higher than the boiling point. When the boiling slows down or stops, then we know that they are at the same temperature. And what I'm going to do next is put my gloves on because safety is paramount. And I'm going to reach in and see if I can get that rubber ball out. I'm going to try to use these tongs here. See how the liquid is not boiling as much as before? When I put the tongs in there, it starts boiling again because the tongs are at a warmer temperature than the boiling point of liquid nitrogen, which is minus 196 degrees Celsius. So now I'm going to retrieve the ball. There it is. I'm going to come walk over here, and I'm going to try to bounce the ball and see what happens. Right here, right here. You see it right here, right? You've been a fabulous audience. You've come here and you have shared the joy of science with me as I have shared it with you. The creativity that the youngsters have, the adults have, all of us are committed to doing good in society. And that's why I want to thank you very, very much from the bottom of my heart. And I ask you to watch this last experiment I'm going to do here. And invite I want to invite everyone who was in the show to join me, and you give everybody a very warm round of applause.